This presentation is for the Engineering Services for the City of Mankato, Minnesota Water Resource Recovery Facility Effluent Disinfection Improvement. The Mankato Water Resource Recovery Facility provides wastewater treatment for the people of Mankato, Minnesota. The facility opened in 1956 and has undergone many improvements, including a facility for reuse water that is shared with the nearby Mankato Energy Center. With the opening of the reuse facility and general aging of the current disinfection system, an upgrade is necessary. The city is considering a new treatment option that will reduce costs and increase environmental feasibility. Existing effluent standards must be maintained regardless of the chosen treatment method. Figure 1 on the left side of the poster shows the location and proposed area for the project in red. The project drew the Ripple Engineering and Consulting student design team together with professional engineers, plant operators, and equipment manufacturers. The students represented the structural, geotechnical, environmental, and hydraulic engineering specialties of civil engineering, along with 2 practicing professional engineers as the team mentors. The students considered design alternatives, handled ethics and business questions, and prepared designs for review. 3 design alternatives were created and evaluated as part of the preliminary design process. Alternative 1 utilizes the existing chemical chlorine process in a new contact basin. It does not change the existing plant flow and requires the construction of large concrete chlorination and dechlorination basins. The second alternative uses ultraviolet light disinfection to treat the full wastewater flow instead of chemical chlorine. It requires the construction of a smaller concrete structure, however it changes the current plant flows and requires costly pumping upgrades. The third and final alternative is divided stream flow system, which uses ultraviolet light disinfection and does not change current plant flows. It was chosen because of its high-quality effluent, small spatial footprint, and low operational cost. An example of this UV system can be seen in Figure 2 in the middle of the poster, and a rendering of this alternative is shown in Figure 4 on the right. The Trojan UV Signa system was chosen for the Mankato Water Resource Recovery Facility. This design has many advantages, including a self-cleaning mechanism. This keeps the system online and reduces the need for operator maintenance. One bank can be taken out at a time while the others continue treatment. This system can also be located completely outside without any problems. The power needed for the new UV system will come from one of the current feed locations at the facility. A plug flow reactor in-pipe static mixer will be used to dechlorinate the chlorinated reuse water that is used at the Mankato Energy Center. This return flow will be fully dechlorinated within the pipe before it reaches the rest of the facility flow and is discharged into the Minnesota River. Figure 3 in the middle of the poster shows the final design and other facility buildings surrounding it. This new UV system has a 99.9% guaranteed disinfection treatment. It will also reduce the production of disinfection byproducts, which is a side effect of traditional chlorine disinfection. The new UV channel will be built 2 feet above the 100-year floodplain elevation, which will secure that no wastewater contamination is caused by rain overflow. Because of weak soils in the area's subsurface, deep pile foundations will be used to support the concrete structure. The design includes 2 channels of 55 feet in length, 4 feet wide, and 7 feet in depth, and the UV channel process piping is designed to account for variable flows. The Ripple Engineering and Consulting team has projected that the construction phase will last for at least 1 year, with a proposed capital cost of $2.2 million and an annual operational cost of $40,000. In this project, the students applied their engineering curriculum to a real-world problem. They used their knowledge of civil and environmental engineering to evaluate alternatives, consider risk and benefits, and create a viable final design, while meeting the time and budget constraints of their client and internal organizational structure. Their interaction with mentors and other members of the engineering profession helped them develop their communication skills and gave them insight into ethics, professional responsibilities, and logistics of taking a design project from initial idea and planning to completion.